Alright, number 8 problem is log base 2 of x squared plus 5x equal log base 2 of 6. Okay, so we look at the equation. We noted that they both have the same base. Log have the same base 2. So we can cancel the base 2 out on both sides. So we end up with x squared plus 5x equals 6. Okay, so the next step is move the 6 to the left hand side by subtracting 6 on both sides. And we end up with x squared plus 5x minus 6 equals 0. Now we need to factor this out. So what two numbers that multiply that give us a negative 6, and then add will give us a 5. So that two number is going to be 6 and minus 1. 6 times negative 1 will give us negative 6. When we add them together, we get 5. So that looks good. So next, we're going to rewrite it. X plus 6 times x minus 1 equals 0. And we're going to solve for x. So x equals negative 6 and x equals 1. Again, we need to check for extraneous solution by plugging negative 6 into the equation, into this equation, to see if we have a negative number. So log, where we see x we will play with negative 6 plus 5 times negative 6. So that gives us a negative 6 squared will give a positive 36 minus a negative 30. That gives us a 6, a positive 6. So this looks good. Okay, so x equal negative 6 would be a valid solution. Next, we need to check x equal to 1. Log base 2 1 square plus 5 times 1 and we got 1 plus 1 square equal 1 and 5, and that also a positive number. So both answers are the solution. Alright, let's do number 9. Number 9 say log, number 9, log 4 and 4x minus 3 equal plus 6 equal 4. Plus 6 equal 4. Okay, so the first step is we need to get rid of the 6. And to do that, we subtract 6 on both sides. So we go subtract 6, and on the right hand side we have a negative 2. On the left hand side we have log 4x minus 3. Okay, now in order to solve for x, we need to get rid of log. Okay, so how do we get rid of the word log? By what's the opposite of log? The opposite of log are exponential. Okay, so we're going to raise in log by default is base 10. So we're going to go 10 log 4x minus 3. And we raise 10 here. We must also raise 10 over here. That gives us the negative 2. And by doing this, we cancel this out. Now we have 4x minus 3 equal 10 that, which also same thing as 1 over 10 squared, then 4x minus 3. Now this gives us 100. This on the left hand side is 4x minus 3. Now we're going to solve for x by adding 3 on both sides. Plus 3. And then the next step is we're going to divide by 4. Next, we're going to use the calculator and figure out what's the answer for that. Alright, so when we punch in the calculator, we end up with 0.7525. 0.7525. Okay, with log, we must check for extraneous solution. So we go log 4 times 0.725 put in the C plus 6. And as we can see, this look like gonna be it will become a positive number, so we know this is valid. Right. The next problem is number 10. It looks something like this: log base x 3x squared minus 10x plus 12 equal to 2. So we need to get rid of log, and the inverse of log would be exponential. We need to put it in an exponential form. To do so, we're going to raise x log x base x 3x squared minus 10x plus 12. And on the right hand side, since we're going to raise this x, so it also have to be x squared. Whatever we do on the left, we must also do on the right for the equation to be balanced. Now we have raised this x, exponential x and log x are the inverse of each other, so they cancel out. So next we're going to rewrite it 3x squared minus 10x plus 12 equal x squared on the right hand side. Alright, now we're going to factor them out. To do so, we need to move the x squared on the right hand side to the left by subtracting negative x squared. If we do that, we must do on the left as well. So we end up with 2x squared minus 10x plus 12 equals 0. We look at this quadratic equation. Can we factor out a 2? Make it smaller, easy to do. Yes, we can. So we're going to factor out a 2. That gives us 5x plus 6 equals 0. Alright, so now we're going to divide by 2 on both sides. And we're still ending up with this x squared minus 5x plus 6. And this side equals 0. Okay, so we're going to ask ourselves what two numbers that multiply will give us 6, and when we add will give us negative 5. The number had to be 1 and 6, and the 6 will take a negative number. No, that will not work. It had to be a negative 3 and a negative 2. Multiply up, give us a positive 6, add will give us a negative 5. So the answer is going to be x minus 3 and x minus times 2 x minus 2. And we solve for x, we're going to end up with x equal to 3 and x equal to 2. Okay, again, we cannot just say we're done. We had to check for extraneous solution. So wherever we see, we had to go back to the equation up here. Wherever we see x, we will play with 3. We check for 3 first. Log 3, and then we said 3 square minus 10 3 plus 12. Okay, so this gives us 27. 3 squared, 9 times 3 is 27. This gives us negative 10 times 3 gives us negative 30, and then plus 12. Clearly this will become a positive number. It's going to be greater than 0. So this is valid. So x equal 3 is in valid solution. Alright, so next we gotta check for x equal to 2. We have to do the same thing. Log 2 3 x squared minus 10 2 plus 12. Alright, so 2 squared times 3 give us 12. Minus 20 plus 12. So the result will be a positive value. So the result positive value, so which is good. So we know that x equal to 2 is also an answer, a solution. Alright, the next problem is number 11. Log 2 log base 3x equal 4 log base 3 equal times 3. Alright, again we need to use the power rule to move the 2 up here. That gives us log 3 base 3 3x square equal, we had to do both sides the same way. We had to move the 4 using the power rule, move the 4. Alright, the next step is we see that log on the left and the log on the right are the same, had the same base, and therefore we can cancel each other out. Now we're going to multiply them up. 3x squared will give us 9x squared, and 3 raised to the 4 power is 3 times 3 times 3 times 3 times 3, which is 3 times 3 times 3 times 3, which is 81, and 9x squared. Now we're going to solve for 9. We're going to solve for x. We divide by 9 on both sides. We're going to end up with x squared equal to 9. And we take the square root of both sides. And x equal plus or minus 3. Next, we're going to check for extraneous solution. When check x equals 3 first, positive 3. So clearly, if we plug in 2 log 3 and then 3 times 3, we will have a positive number. So this is valid. And so we know that x equals 3 is valid. So we circle that. That's one of our solutions. Then we need to check when x equal to negative 3, and this will not be valid because we see 2 log 3 times negative 3 will give us a negative number, and this is not valid. So therefore we can cross this answer out. So the final answer is x equal to 3. Moving on, number 12. Log base 2 of x squared minus 3 equal log base 2 of negative 2x. Alright, we look at this, the left and the right, they both have log and they both have the same base. So therefore we can cross log base 2 out. So we end up with x squared minus 3 on the left and then negative 2x on the right. Now we're going to move the negative 2x from the right to the left. That means we're adding 2x to both sides. And that gives us x squared plus 2x minus 3 equals 0. Now we need to figure out what two factors that multiply that give us negative 3. And then when we add, will give us a 2. So that had to be a 3 over here plus 3 and a negative 1. We multiply in negative 1 times 3, we get negative 3. When we add them together, we got positive 2. And that equals 0. Now we're going to solve for x. X equal to 1 and then x equal to negative 3. Again, we must check for extraneous solution. Now we're going to check for x equal to 1 to see if that's a valid solution. So we go up here, we go up to this equation up here to make sure we have no negative. So if we go and we say log 2, where we see x, we will play with 1. And this look like an invalid solution because the answer up here will give us a negative 2. Right? So this is, we cannot have a negative number for log. So therefore, this would be invalid solution. Next, we checked for x equal check for negative 3. So we go do the same thing where we see x, we will play with a negative 3. So that would be negative 3, and then we square them up and minus 3. 9 minus 3 is a positive number. so which is 6, which is good. So this is a valid solution. All right. Number 12. That was number 12. Moving forward. Oops. No, we're not done yet. We had to check on this side. So far we only check on the left, but we forgot to check on the right. So we gotta go back and do check x equal -3 on the right. Clearly, log 2 -2 times -3 will give us a positive number, which is 6. It's also a positive, so it's good. So we good. Now we are done. We gotta check both sides, just not one side. The next problem is number 13. Log 2 base 2 x minus 3 x minus 2 square, no, not square, cube equal 3. Alright, to solve this problem, we need to get rid of block base 2. The way to get rid of block base 2 is by the inverse of block base 2, which is we need to write in exponential form. So we can say 2 log base 2 x minus 2, and then if we raise this by a 2, we need to raise it by not raise if the inverse of log 2 is 2 exponential 2, so this is the base 2 of exponential 2. So now both have the same 2 to log 2 can cancel out, so this can be written x, and that 2 times 2 times 2, that gives us 8. Okay, what is the rule of the differences of the cube? Something like that. A, B, thirds is become A minus B equal A square plus AB plus B square. Right. So as you can see, this look like this, x minus 3 to the cube. It look like differences of the cube. So now we can substitute in, and we say on the left hand side we're going to have x minus 3 on the, and then x square, and then plus oh, come on, this had to be a negative. Alright, the next problem we have here is number 13. It's saying log base 2 of x minus 2 to the cube equal 3. Okay, so we need what the inverse of log 2 is. Exponent. We need to write it in exponential form. So it had to be log 2 x minus 2 to the cube. And on the right hand side we had to do the same thing. 2 to the third, which is 8, and this cancel out. This is x minus 2 to the third. The next step is we need to find the cube root of this. We need to cube it. Cube root of this. That gives us x minus 2 and over here that gives us 2. And then we solve for x, so x equal to 4. Now we gotta check for extraneous solution again. Check x equal to 4. To do so, we do log 2 4 minus 2 to the third. Right? To see if we get, we must have a positive number. So obviously this is a positive number. The result is a positive number, is 2 to the 3, right? And which is equal to 8. That's positive number. So this is a valid solution. Alright, next, number 14. Log base x plus 1 2x squared minus 7x plus 19 equal to 2. Now we need to write this in exponential form, and that would give us what the inverse of log is exponential. If we also have to do the same thing on the right, whatever we do on the left, we must do the same thing on the right. Right, and this go away, this cancel each other out, so we end up with 2x squared minus 7x plus 19 equal, and we go ahead and multiply this guy out, which gives us x squared plus 2x plus 1. Now we're going to bring the equation on the right to the left, so we're going to subtract x squared minus 2x and then minus 1, so that becomes negative x squared minus 2x minus 1. On the right would be 0, on the left would be x squared minus 9x minus plus 18. Alright, so we use the AC method to factor this one out. A equal 1, B equal negative 9, and C equal 18. What two numbers that multiply give us 18 is 2 and 9, but when we add, will not give us negative 9. How about negative 6 and negative 3? They both multiply give us 18, but when we add, we got negative 9. So this would be x minus 6 and x minus 3 equals 0. Now we solve for it, x equals 6, x equals 3. Check for extraneous solution. X equals 6. Now clearly we plug in this x into this equation up here. We can see that we will have a positive value. So if I plug in 6 up there, I will have a positive value. Go 2 times 6 squared minus 7 times 6 plus 19. Clearly this will give us a positive value. So x equal to 6 is good. We also need to check x equal to 3. Now this one we have to do 2 times 3 squared minus 7 times 3 plus 19. Clearly it's still going to be a positive value. The result of this is a positive value. So it's also a valid solution. It say natural log 3x plus 5 squared equal to 4. Okay, so we're gonna use the power rule to help us. We're gonna rewrite it in this 2 right here can move up in front of the natural log because of the power rule, the rule. And now we're going to divide by 2 on both sides. Make the number smaller. And then at this point we need to look for the inverse of natural log, which is e. And we also have to do the same thing on the right hand side, e squared. This go away. Now we have 3x plus 5 equal e squared. Now we're going to solve for x, so we're going to subtract 5 on both sides. And we got 3x. And then we solve for x, we're going to divide 3 on both sides. And we're going to do the square of e squared. Using the calculator, we will figure that one out. So the e squared will give us, punching the calculator, we got a rough idea because it's not the exact number, 3.389 minus 5 divided by 3, and we get something like 0.796. Now we check for the solution. Definitely this is going to be a positive number. If we check for external solution where x equal 0.796, we plug them in. Clearly it will be a positive number. But I'm gonna write down anyway. And the result is going to be greater than 0, positive. So this will be a solution. Alright, the next problem is number 17. And it's a log base 4 of 2x squared minus 4x equal to 2. Okay, we need to write this in exponential form. Okay, so this would give us 4 log 4 2x squared minus 4x, and over here we're going to do the same thing, 4 raised to 2. Alright, so this cancel out, and we have 2x squared minus 4x equal 16. And then we move the 16 over, we got 2x minus 4x minus 16 equals 0. Now we're going to factor out the 2, make our problem easy to solve. So that becomes x squared minus 2x minus 8 equals 0. Divided by 2 on both sides. And we end up with x squared minus 2x minus 8. Now we're going to factor them out. What two numbers that multiply will give us negative 8? When add will give us negative 2, so it has to be a negative 4 and a plus 2. Multiply them up, 2 times negative 4 give us negative 8, add will give us a negative 2. So now we're going to solve for x. X equal negative 2 and x equal 4. Next step, we need to check for external solution. Check x equal negative 2. Where we see x up here, we replace with a negative 2. and we make sure the result had to be a positive, because log cannot be a negative. So we go log 4 2 times negative 2 squared minus 4 times negative 2. So clearly this have to be a positive result, have to be a positive number, because this is 8 and then plus 8, that's greater than 0. That's the positive number. Next, so we know this is valid. We checked for x equal to 4. Again, we plug in where we see x, we will play with a 4. And 16 times 2 is 32, minus 16 clearly is greater than 0. So both answers are valid. Number 19. Natural log square root x minus 1 equal to 2. Alright, so I'm going to rewrite this in exponential fraction. Log n x minus 1 equal 1/2 2. And I'm using the power rule to move the 1/2 out in front of natural log. So that becomes log x minus 1 equal 2. Next, I'm going to multiply 2 on both sides. And that becomes 4. Let's go away. Log x minus 1. Next, I'm going to find the inverse of natural log, which is exponential, which is e, not exponential. That e to the 4. Just go away. Next, it becomes e to the 4. And then x equal e to the 4 minus plus 1. Okay? And I'm going to use the calculator to figure out what e to the 4 is. So, I punch in my calculator, e to the 4 equal 54.598 approximately. So, plus 1, and we got approximate x equal approximately equal 55.598. And clearly, we checked for this, check for x equal 55.598. You see that about the solution. But plug it in into this equation above. So log 55.598 minus 1 is going to be greater than 0. So it's valid. Okay, this would be the last problem that we saw, number 20. It say log base x minus 1, 6x minus 14 equal 2. So we need to get rid of log by using using base 10. So 10 log, no, I'm sorry, not base 10, but write it in exponential form. X minus 1 log x minus 1 times 6x minus 14, And then on the right hand side, since we use x minus 1, we also have to do the same thing. This cancel out, so we have 6x minus 14 equal x minus 1 square. Nope. Now x minus 1 square give us x square minus 2x plus 1. And over here we have 6x minus 14. So we're going to move everything from the left to the right this time by adding 6x, subtracting 6x and adding 14. On the right hand side we do the same thing. X squared minus 2x plus 1 minus 6x plus 14. This gives us x squared minus 8x plus 15. Alright, so we need to figure out what two numbers that we multiply that give us 15. And when we add, will give us a negative a, which is negative 3 and negative 5. And going to be x minus 3 and x minus 5 equals 0. So x equals 3 and x equals 5. At this point we have to check external solution again. So clearly we go check x equal to 3. That's the first thing we're going to check. So now we go log 3 minus 1 and then 6 times 3 minus 14. This will be greater than 0. So 18 minus 14 is 4. So this is valid. Again, we must check for x equal to 5. Plug in. When we see x, we'll play with 5. X minus 1, and then on top we 6, 5 minus 14. Alright, clearly this is going to be greater than 0, so that looks good. So we done all this problem, and I will see you guys next time.